In this video, let us try to solve homogeneous linear system of equations. Suppose if a linear system of equations which are homogeneous are given, let's see how to solve such equations. Here is an example. The question says, solve this system of linear equation where the coefficient matrix is given. So in this case, only the coefficient matrix is given. Now, in order to rewrite this coefficient matrix, I know that these are the coefficients. The first column is the coefficient of x, second one is the coefficient of y, third one is the coefficient of z. And since it is just the coefficient matrix and it is homogeneous, you know that the constant is all 0. So when I rewrite these equations, the first equation gives me 1x plus 0y plus 1z equal to 0, which is x plus z equal to 0. And the second equation is 0x plus 1y plus 0z equal to 0, or y equal to 0. And the third equation is true equation 0 equal to 0. So in this system, I have got only two non-zero equation. So since I have got only two non-zero equations with three unknowns, I know that this will have infinite number of solutions. So when I want to solve such equations, take the backward substitution. So take the lowest value, take from the bottom. So the z value can be taken as a parameter t. If z is t and already y is 0, so no need to change anything there. But from this equation y is 0. In the first equation I have x equal to negative z, which is negative t. So I get the solution for this where the x value is negative t, y value is 0 and the z value is t. So this is the solution for the given system of homogeneous equation. Let's try another equation. I have another equation here in terms of 1, 2, 3, 4 columns. So I have 4 unknowns. So maybe I can take these unknowns as x1, x2. Let me take this values clearly. So you have x1, x2, this is x3 and x4, and again it is homogeneous, so the constants are all 0. Now when you plug in, when you rewrite this equation, you know that it is 1x1 plus x4 equal to 0 from the first equation. 1x1, 0x2, 0x3, 1x4 is 0, so x1 plus x4 is 0. From the second row, I have 1x3 is 0. And the third one is all 0. So since I have just two equations, non-zero equations, with 4 unknowns, using the backward substitution from the bottom of it, if I am treating x4, starting with x4, I can take that as a parameter t. x3 is already 0, so I have x3 equal to 0. Now, I do not have any equation in terms of x2, so I have to take a parametric value for x2. Since t is already taken, the next one will be t. So always take the values, the parameters when you start with, you take t, give preference to t, s, and then r, like r is t. T is the first one parameter, the second assumption will be s, and the third one will be r. So I started with t. For x2 I am taking the second choice s, and x1 from the first equation I get x1 equal to negative x4, which is negative t. So since I know these results, I know that the solution for this is x1, x2, x3, x4, which is negative t, s, 0 and t. So that is my solution for the second equation. You can also, instead of getting these equations, you can also plug in those values in your graphing calculator, try to find the reduced row echelon form of it and do it. Since the coefficients are just 1, 1, 1, no need to make use of the graphing calculator. Let us see this type of equations here. Now you have a system of equations. These are not homogeneous. You have system of equation in terms of three unknowns. You have three equations, three non-zero equations with three unknowns, x, y, z. The question here is, you have to solve the system by taking only equation 1 and equation 2. So in equation 1, I have 4x minus 2y plus 5z equal to 16. That is my equation 1. And the second equation is x plus y equal to 0. So the easy way is to make use of the graphing calculator to find the reduced row echelon form, the Gaussian elimination. So for which I am trying to take the augmented matrix, that is the coefficient along with the constants. So the matrix A will be 4, the coefficient matrix are 4, negative 2, 5, and the augmented constant will be 16. From the second equation, I have 1, 1. I don't have any z value, no constant. The constant is 0, so I have a matrix A which has got 2 rows and 4 columns. So I'm going to enter this 2 rows and 4 columns, this matrix A, in my graphing calculator. So if I select my graphing calculator, say matrix, I'm going to edit the matrix A. Let me edit this first matrix. It is a 2 by 4 matrix. So I have edited that 2 by 4 matrix, 4, negative 2, 5, 6, 25, is it 26? I think it is 16. 4, negative 2, 5, 16. And the second one is 1, 1, 0, 0. Yes, I have entered these results, and once when I enter, I can quit the screen and select my matrix again. Now this time I am going for math part of it, where I can find the reduced row echelon form. Select your reduced row echelon form, and I want the reduced row echelon form of this first matrix what I have entered. So when I select, I get this as my answer. These are all decimals. I don't want that in decimals. I want that to be in fractions. So click math, select math. Under that, the first one says fraction. So I want my answer to be in fractions. So select fraction and enter. So all your values will be given as this is what you are getting, the reduced row echelon form of this given matrix if I have entered it correctly. If I have entered those values 4, negative 2, 5, 16, 1, 1, 0, 0, make sure that you have entered the values correctly, and this is what I am getting. So the reduced row echelon form of the matrix A is 1, 0, 5, 6th, 8 third, and then you have 0, 1, negative 5 sixth, negative 8 third, so I have 16, 6. Okay. So from this equation, these are all the coefficients for x, y, z, and this is my constant. So if I rewrite this, it looks like I get x plus 5/6 z equal to 1/3. Y is 1, y minus 5/6 z equal to negative 1/3. So from these two, it looks like I have only two equations for three unknowns. So again, starting from the bottom value, I am taking a parametric result for z. Let us take z as t. When z is t, from this equation, second equation, I get y is equal to negative 8/3 plus 5/6 z, which is negative 8/3 plus 5/6 t. And from the first equation, I will get x equal to 8/3 minus 5/6 t, z, which is t. So the solution will be 8/3 minus 5/6 t. Then negative 1/3 plus 5/6 t, comma t. So that will be the solution for the first two equations. If you are taking only two equations, this will be your result. The same way, if you have to find the solution for equation 1 and 3, take only equations 1 and 3, make use of the same case. Enter that in your calculator, find the reduced row echelon form, and I think even there you will get a infinite solution. So you have to have a parameter. Start from the parameter t always. If there are two unknowns, then maybe you will have the second one as the second choice as s. But here I have a t, and with respect to t, you can rewrite the values of y and x. So the same way you can try the other questions. What about this one? The question says, graph the two equations. It looks like when you see a small window, it looks like they are parallel. But when I see these equations, 100y minus x equal to 400. So when I write y is equal to mx plus z form, you will definitely have two different slopes. The slopes of the two equations are not equal. So in which case, the two lines are not parallel. So if you solve this manually, you can solve it by elimination method, substitution method, whichever method you have, because it is a simple equation just in two unknowns, x and y. Or maybe you can make use of the calculator also. You can find the reduced row echelon form of x. The x coefficient is -1, y coefficient is 100 for the first one, 400, -1, 99, -396. Then this will be reduced to some equation, say 1001, and you may have some values. So you know this is the coefficient of x and y. You know what is x. X value is this. Y value will be this. So you can find the solution for those two by solving the equation. It's not necessary that you have to make use of your graphing calculator. You can just try that by solving the two equations. Hope this small video was clear to you to find the solution for homogeneous equations. Thank you for listening, and thank you.